Okay, so I am going to record just walking through some of this part. I'm just going to walk through it as I would process it. Remember, this is brand new for a lot of us, so it's okay to have some mistakes and to have not everything work out right. We've got a pretty tight timeline on these first three parts. They don't have to be perfect, so I don't want to say I'm really curving it, but what I want to do is I want to just start learning how to apply some machining to parts that we've drawn. So what I've got is I've redrawn this part M1 or from the Titan, and so I'm in Inventor and I'm going to walk through this part of it because I think Fusion, the Titan's CNC video really gives you a good idea of what it looks like for Fusion. So I've got my part imported in. I'm going to go ahead and go on over to the second tab and setup. I'm going to use this fixed size box, 4.1 by 2 by 1. I'm going to take my position from the top and I'm going to go down 50 thousandths. So what I've done is I'm putting my part just right down below inside of that stock box. So this yellow box is our aluminum before we've cut the part. So if I go to my third tab, it's just whatever program number I'm going to start with. I just picked 1000 just for no reason. So I've got the option to do turn mill or mill. I'm milling. That should be your default to go to anyways. As far as where I'm going to place my 0 point at, we talked about it a little bit in class about where the best place to put 0 is. You've got a couple of options. You can go in and you can go to the model orientation. You can put it at any kind of point. Here is where we kind of left it off yesterday. That's at the 0 point from drawing it in the part itself. So it's actually inside of where the stock is. The advantage of that is when we create a program, all the dimensions are awesome and correct. Another place that we can put it is we can put it in the middle of the part. That's where we had it the other day. And we can also kind of just choose to put it wherever we want. So if we move it up here, and so what I've done is I went to select X and Y, and from selecting X and Y I can then kind of put it wherever I want on whatever edge that I want it to be. So I can move it to the center point of a hole, move it however I want it to be or wherever I want it to be at. So I've got my part. I've got my XY setting at the edge of the stock itself, and so let me go back in here to setup, and so I can go to the model origin. I can go to a selected point, stock box point, or model point, and so here's where I'm at up in the corner under select X and Y. Okay, so that takes care of our setup. And go back to the front, take a look at our part, do a quick rotation around it just so I can see all the way around it. So now that I know where my part is, I've got my part drawn up, and I need to start applying some machining to it. So we're going to do a lot more than what we did in class the other day because we just did some holes and then some stuff on the inside. So what we're going to do is we're going to start with the face option under CAM, and so we're going to go to face. First thing that's going to come up, it's going to ask for what tool we're going to use. We're going to go into the library. We're going to pick tool number 1 is 2-inch face mill. So you can go into all tools and you can go to diameter is 2. You can go in and see a 2-inch face mill. If you don't have one, you can make one. So you should have one though, so that shouldn't really be too much of a problem. That's pretty standard. One that you can pick out of there. So we got a 2-inch shell mill, 2-inch shell mill, face mill. And so it's going to bring it in at the 0 point, and then it's going to really just kind of want to start knowing where we're going to put the part at. So stock selection, and I'm going to click on that, and I want to click on this outside edge of the part. That's the outside edge of the finished part. And from there on out is just my clearance heights, how my tool is going to process. Do I want to overlap on anything around it, and then how do I want to fine tune some of these things? Right now, all I really care about is is just kind of getting down and dirty on this part. And so in doing that, we can just click OK. And from there, it's going to generate the code. It's not a perfect face melt pass, but it's one that we can live with. So we're going to simulate it. And by simulating it, we're just going to go up to simulate in the upper left-hand corner, run across it. We want to see what it looks like. Front, rotate this thing back over. And so first pass is awesome. Second pass is kind of crummy because it really leaves it to just the edge over here. So I'm going to leave it for now just because I know what it is that we're doing. And again, we're just in the very early stages of doing these things. So if I want to go in and change this name of this face melt, I can. I'm going to come in, click it again, and then I can go face melt. And if I want to, maybe I want to say it like this. Turn my caps lock off. 2-inch face melt. So it's tool 1. All those things can be changed as we go. So yesterday I would come over to this section, the browser part, and I would just kind of right click and go to new operation. Second way of doing that is to go just up into the cam tab and hit 2D contour. 2D contour is going to bring back my last thing that I was doing. I don't want to do that again. I want to go in and change tools. I want to go to a 1/4 inch flat end mill. What we didn't look at yesterday was going in there and kind of seeing some of the information about it. So we can see kind of spindle speed and some of the other options that it's going to have for that. And we really just want something pretty simple. So we're going to select that guy. And now we're going to go, just like we did before, we're going to go around our contour. And what I want to pick on this is the bottom of this part. This arrow is going to show the direction that my tool is going to cut, so my tool is going to remain on the left-hand side of the part. It's going to cut down to 750 thousandths, and I can hit OK. If I want to watch it run, go in. It looks like when this tool was set up, it's red because it sees collision, and so if we kind of go like this, let's see, we'll zoom it up and rerun it. What it doesn't know is flute length. I know my end mill is longer, so this darker area is flute length, and it sees that it isn't able to do that. But our 1/4 inch end mills have a flute length that's going to be a little bit more than that. So I've got one right in my hand, and it measures 800 thousandths of flute length. So we're going to be really close on getting that done, but I think that's going to be able to be okay. And again, on first parts, we're really not concerned about parts. We're really concerned about process. All right, so if I want to change the name of that, I can go in and make it, still leave it tool 2 if I want to, and then I can just call it a 1/4 inch 2 flute. Learn how to type. 1/4 inch 2 flute carbide end mill. Okay, takes care of that. From this point on, I can use this tool for quite a bit. I'm going to go ahead and do this little funky section here, and for that, I'm going to go to maybe something just a little bit different in what I would normally do. And I want to let me show you a couple different ways of doing it. So we can go back to do 2D contour, and we can select this edge right here. It automatically shows us our direction. We can hit OK. Now, that works, but you can see it's really only one pass going in through there. It's a pretty solid cut for what we're trying to do. So I don't like that, and so what I'm going to do is I'm just going to delete it. While I'm here, I'm going to go ahead and save. What you don't want to do is get knee deep into this thing on your last tool and have the power go out or something crazy happen to you, and you'll lose all every component, every feature that you've done so far. So save often. And so I'm going to go into 2D adaptive on this part. And so what it's going to do is it's going to take the part that I have, and it's going to start doing some work to try and figure out what's going on inside of it. So second tab, I go over to geometry, and click it and find my part. It's not exactly what I want. Go back and re-click it. Let's see what that looks like. And just highlight it. Now, what I don't really like about that is that it's running all the way down it. So I don't think I'm going to keep it. Just going to go in and delete it. Could go back in and reselect it. So let's go back and go 2D adaptive. Let's go back in here. Select our pocket. Now, we're selecting just the pocket itself. Now let's see what it looks like. Simulate. Oh, let me go back. Just that tool. I just want to simulate that one, so I need to highlight it. Simulate. It's a lot better. Now I'm just going to be doing the work inside of that area. That way I'm not trying to mill this outside area that I've already milled. Okay, I like that. Now I can call that whatever I want. I can leave it alone. I mean, it's really still the same tool. It's all still the same stuff going on in there, so I'm just going to leave it alone. All right, so I'm going to go ahead and just pan over just a little bit so I can see this whole thing. Maybe flip it down just a little bit. Now, I'm going to go in and I'm going to stay in 2D, and I'm just going to go to a 2D pocket. Same tool, second tab. Choose the bottom, hit OK. See what it looks like? Now, I've got my single scroll where I came into it, and yesterday when we talked in class we had a couple different ways of doing it. So this is just a pocket. So let's simulate it. Scrolling down, or spiraling down, it's going to get all the way down to depth and then kind of work from there. It's a pretty healthy cut for it to be taken. I have not done any type of changing around of any of the stuff inside of it. When I'm looking at something like this, I am a little concerned about tool breakage because I've got a lot of stuff happening inside of there. I've got my tool right down on top of that, and not a lot of space for coolant to be able to get in there and do any kind of work. So while we're here, I want to play with this one just a little bit. I like it, but I don't necessarily love it, so I can leave it there, and then I can go into I could even do maybe a 2D contour on this and see the inside of this thing, and choose the bottom of it. Come over here, contour selection, go right there. It's on the inside. See what it looks like. Oh, now that'll definitely do it, but it's going to leave a huge island in the middle as I go through and run that thing. Because all it's doing is it's running on the right side, it's going the right way, but as it does that, kind of imagine that some big chunks left up inside of the middle of there. That's not going to work. So we've got to close it, we've got to get it out of there. That one's just not going to work at all. Okay. So we could even, if we want to, just to play around just a little bit, we could look at some of our other options in here. That's probably about it there. We could even look at see what adaptive looks like over here, just for fun. So same tool. Go back in, second tab. Choose this area down here. Adaptive is going to run the entire part. Now, pros and cons inside of that. I love the fact that it's doing a couple steps down inside of that, but it's not giving me a lot of other options. Now, overall, I kind of like the way that part looks like. So if I were to just run it, let's just see what it looks like. So it's taking some steps down as it goes through the outside. I knows it's got some work to do inside of there, so it's going to try and chew out as much material as possible as it goes. What I don't love about it is that sometimes it feels like it goes all over the place. If you've machined for a long time, some of those sequences don't seem right, but in the end, you're really only talking about losing milliseconds at a time. And it's decision making. It's trying to stay in a better spot. That's a pretty good cut that is taken. It's trying to stay about 80% engaged as it goes through there. It's making a lot of radial cuts. It's going to go through and it's going to rough that entire thing out. It's going to look pretty gnarly in the beginning, but you can see it also has a profile cut that's going to go all the way around it. So just chop it out, all the rest of the material. When it can't get done, so you just keep working out. So if you see, what we have here is two separate levels of machining. So pros and cons on that. We can't control what's going on here as much, because what we've said by doing an adaptive, especially in a 3D part, is we're saying, okay, I'm going to let the machine do the controlling of what's going to happen. So that means I can't force any particular functions that I want to have happen to it after the fact. So that is an option that I would totally let you try. So if you wanted to just run that, you can. It's not going to stop the fact that you're going to still need to do a face mill cut, and you're probably going to need to still go around it and maybe do some finish passes. So like, you might want to do something like this. So if you wanted to do adaptive, let's just leave that alone like that. So we've got a pocket cut, and then we've got an adaptive here. We could really, we could keep that cut, we could take this cut, we could take this cut out, and we could delete those. We could leave our adaptive cut here, and we can take this here. So we still have our face mill. We have a milling around the outside of it with carbide end mill, and then we could move these around inside of there. So we're going to face mill, then we're going to adaptive cut the inside and outside, and then maybe we'll take a finish pass around the outside. And then if we need to, we can come back and do this contour like we had up there before. So we know the inside of it, we know what it's supposed to look like. The floor of it should already be done. So really, these become kind of safeguards just to make sure that everything comes out to be that right size. And I think we could probably even do a 2D contour on, let's see if we can just do it over here on this one. Yeah, let's see what that will say. And so we would just consider these finished cuts to go around the part. And so simulate that. Just that last section of it. Okay, looks pretty good. I don't know that I would say that would be my best case scenario in it, but I think it's kind of fun to try. So if I were to look at this entire setup from here and to simulate it, speed it up just a little bit. We've watched it a few times. Face mill cut. Adaptive section, chewing out all this material. Staying really engaged in the cut. It's doing some multi-depth stuff, so we don't have to worry about just being full depth in that end mill cut and having cooling issues. It does do some things that, as I look at it, I'm not super in love with, but when we're cam milling, there are some things that we have to kind of give up as far as being in control of every single move that it makes. We can definitely control every move if that's what we need to do. So these are our finished cuts. That's it. It's pretty good. I'd be interested in trying it. So if you want to try it like that, if you're a control freak and you want to have control of all this stuff, then kind of follow through what we were doing just a minute ago when we were just doing a pocket. So we can come in here and do the pocket. So just go back and look at that. We can come in, we can do our pocket right here and hit OK. And so that's our single spiral down cut at full depth going around it. So if we want to do that, welcome to do those kinds of things. Same thing with a 2D contour or adaptive for this outside. You can do both of those things. I want you guys to be comfortable and kind of playing around, but I don't want to be foolish about, I don't want to break in mills all day long. Okay, so we tackled the holes while we were in class, and so I'll do one hole just to give you a reminder of what's going on with that hole. So we'll just pick any kind of hole on here, and so we'll go to drilling, and we're going to pick a tool, and so I want to use a diameter, and so 3/4. And what I'm looking to find, or let's see, let's go ahead and go on down to 750. Let's see, I need to go to all tools, and let's go back to 3/4 since I'm on all tools. No, still don't see anything really good there. So sample tools, all tools, and let's go back to 750. So all I'm looking for is a 3/4 spot drill. My first choice in all of these is typically going to be the aluminum choice. So it's going to give me some spindle speed options. My material is aluminum that's going for. Okay, so all I want to do is come in a second tab, and I'm going to select the whole face. And to me that doesn't look like a whole face, but it really is. Okay, and so it's wrap it, or drill in, wrap it out. So super cut, quick cut. So you need to do that on all of them. So go through and spot drill all those. That's just a spot drill. So as of now we're 1, 2, and 3 in our tools. It's pretty cool. So next we go to our drill, and we need a number 21 drill, I believe is what we had said. Let's see if we can find a 21, and we'll go by all tools. Not 21 millimeter, but we can go back and figure out what drill size that is. I know that we had said that it was 21. We'll see if we can find that thing in here. 31, 30, 28, 25, 21. First drill is typically for the aluminum. Again, we can go back over here and see. Yeah, aluminum. That's what we're working with. So now I want to go in and drill my hole. And okay. Now, what I don't want that drill to do is do what my spot drill did. I don't want to just plunge in, plunge out. So that needs some work. Go back in, double click it, and I can go in here, look at everything going on here, optimize order. As I'm trying, if I want to try and force the holes, like so, say I've got some really bad symmetry issues in my mind, and I need to go 1, 2, 3, 4, 5, 6, and 7. That's fine. You should probably have some counseling, but let this thing go however it needs to. You're only going to save just milliseconds on there. So I can go in and control this. So I can go in and do what's called deep drilling, and that's going to allow me to do some peck drilling. And so my peck is going to be 50 thousandths, and I don't want to dwell, meaning stop in the bottom of the hole. I just want to let it go. Alright, so now it looks totally different as I drill it. See how it jumps in there. Clears out the chips as it goes. And we want to go ahead and let that go all the way out. So that's a G83 on the code. Okay, so that's tool 4. And I need to tap the hole still. So last option. And go in, and I need a 1032. And go to all tools. And maybe grab some sample libraries, everything, try and find some stuff here. I know we've got a 1032 in here. So let's see if we can find it this way. 190. Alright, I think that's it. 1032. Yep. So that's 1032 tab. And select it. And we're selecting the hole. Now, the only thing I don't like about this one is it's really going to try and go full depth. It's going pretty fast too. So it's already selected for tapping. It's already there. It's going there. Now, if I look here and control some of the stuff that's going on. Bottom height. I want the whole bottom to be 500. So what I want to do, you see it, I change the depth of the hole, what it's going. from the stock top. I can go up there, I can go whole bottom, and so from there I want to stop that hole going down through there. I don't want it to go past 500 thousandths. That's really a pretty deep tapping option for that. 380 it would be standard on it. So I don't care if you chicken out a little bit and want to go to 380. I'm okay with that. All right, so tap and simulate, and there we go. So we're not going as deep as the full as the drill. Drill should go through it deeper. Okay, so that's just one hole, not going through. Don't want to blow through the bottom of this part. Go back down through it. So now I've got tools 1, 2, 3, 4, and 5. I can go up to here by setup, and I can just run the entire part, and we'll run it through really fast. I wish you guys worked that fast. Okay, so I'm pretty happy with that, and let's just go back to some of the other stuff that we talked about, post-process. So when I go into post-process, I need to pick a machine that I'm going to run off of, and we're going to use a Haas, and we're going to use a Haas pre-next-gen control. It's going to be a pretty standard, pretty generic Haas code. It's actually really just a pretty standard generic G code. So there's generating the code for me. Now, what it's given me as tool 1, 2, 3, 4, and 5 is all the information I need to get started. Tells me information about what's going on. It's taken all the tool stuff that I put in there. See how I wrote in there 2-inch face mill, and now it gave me a 2-inch face mill. Tool 1, M6 tool change, 6500, and spindle on, G54 from offset. Some things that I don't like that I want to go in and change real quick is it's got this tool 2, and it's got what that does. It really doesn't affect us at all, but it puts tool 2 in standby. And I want you to get familiar with changing some integers. Integers are the things that allow us to be able to go in and make some changes. And those are some of the things that we talked about before in class. So we go into open configuration. And so then we're left with a whole bunch of programming options and issues. And so how it defines all of the stuff that it's doing, because really it's just pretty simple. I don't want to say simple. It's just a computer program, just making some decisions as we go. So I don't want to do a preload tool. And for me, that's just really, it's just a preference. Sequence numbers, I'm not a huge fan of sequence numbers. So I can false it. And sequence numbers start with, if I do start with 1, I want it to be 100. And I only want them to be on tool changes. So sequence number only on tool change. Yeah, it's true. Optional stop, yeah, totally want to do that. Good safeguard. Show some notes. If I've got notes in there, I can show those. Use G28. So it's going to go back and forth. I'm going to leave that one alone right now, and we'll go back and look at that in a second. It's going to toggle between the G28 or the G53. So a lot of times I have you do tool changes by G28, G91, Z0. The other option for that, as we've talked about before, is using G53. The advantage of that is that you don't have to go into incremental, but the disadvantage of that is not every machine is going to take it like that. For what we're using, it does, so we're okay with that. Let's see. Anything else that I really need to change? Probably not. Most of these things are preference situations. But how you define this and then how you save it and store it, that way you can pull it back up and reuse it. What's really cool about this is that if you jack it up big time, you save it, just as you're making changes, save these things as different names. So I didn't really do anything big on mine, so I'm just going to save it. You can save it as your own configuration. So if I'm Adam, I can change this to Adam's Ultimate Haas Post, and it'll have all of his preference, his favorite ice cream flavor, and any other things that he wants to put in there. So I can close it, and then I can go back into Post, and I can save it, and yeah, I already did that, so I'm going to post it again. So now I've got code that's just a little cleaner. There's no, let's see, no tool numbers in there. And let's see. So some other preference things that I would take out, just kind of as I went. I don't like the way that at the beginning of the tool, so like for me, just personal preference, it says adaptive, so it says what my operation is, then it turns to cooling off. So it really finished my tool out, turned to cooling off, optional stop, change tools, went to 10,000, turned to coolant or turned to spindle on, which 10,000 is too fast for our spindles, but it's going to max out at 8,500. Went to G54 work offset and then turned to coolant on. G17 is XY orientation. And so T2, H2, all those things look good. The rest of this, man, you are not going to be able to grab that code as you go. So you're going to have to just trust in some of these things. So what's cool about this editing program is that it color codes stuff for you. So you've got rapid moves that are in red, you've got feed moves that are in green, and then you've got some of these circular interpolation moves and notes that are also in blue. So you can add and subtract some things on this if you want to. Don't be afraid to go in and play with it. What I would do probably, since we have so many parts to do, we got 3 parts to do, and you guys are brand new at this, and after you go through a box of Kleenex from Tears of just trying to get a handle on this, maybe after you get through with that first or second box of Kleenexes that you can go through and maybe start to play around with some of these things. But right now, I think I would just really worry about just getting a program that actually works. So you want to save that, and so I kind of move on to your next program after that. And so don't be freaked out as you go through this. You guys have got this, and if you're using Fusion, I know a couple of you guys were, and Fusion's got some pretty awesome stuff in it. And so I may do another one of these real quick, and then I might bring up Fusion and do some post options in it. We're going to be talking about post options and refining and defining our posts quite a bit. So even if I don't get it done this time, we'll get it done as we go. And so I really want you guys to be really good at making some changes on the integers and having some posts, customizing those posts. All right.